Peter's joining us again. He presented last year, and during the presentation last year, he referenced the way that he guided the BKW Energy's smart meter operation solution to be really more accurate and swift at dealing with some of the meter failures rather than starting a series of emails to deal with it. So welcome back, and I'll let you take it from there.
Thank you, Steve. Thank you, JT. Love hearing your stories, guys. Very much enjoying, and I will have to carry some of those stories back into my company tomorrow. Can you see my screen?
Yes, looks good.
Excellent. Great. So this particular use case is very straightforward, very simple, and yet it solved an issue within BKW Energy that literally nobody in the company had an idea how to go about it, how to solve it. So let me tell you all about it. Quick introduction, BKW Energy. It's an energy production company, also distribution company. They exist for more than 100 years, located in Switzerland. And about the last 10, 15 years, they've also branched out into building automation and infrastructure, building large infrastructure, projects. They're based out of Switzerland, but there's also companies in Germany, France, Austria, Italy, Norway, and they also finance different production facilities in Europe. Incidentally, my grandfather, he already worked for them. He was the doctor on site for the construction site of the Grimsel Dam up in the mountains. That was in the early 1930s, and we can only guess there on the bottom left that probably were pretty rough conditions that people were working under with storms, snowstorms, and heavy sunshine in the summer. So probably not a easy environment to work in. But going right back to the present, plus 90 years here, BKW already had in place about 80,000 smart meters that were operating. Smart meters are devices that are somewhere in your apartment or in your house or on a production site or so, to basically measure your energy consumption, your electricity consumption. And they also had a goal of scaling that up to a 400,000 smart meters within about a fourth of Switzerland, the space. Yeah. The data, from a data perspective, it looked that way, that on the left-hand side, you see the smart meter. The smart meter would deliver the readings every day over a 3G or 4G network. Then it would be received by the head-end system, by land using gear. The data would be pushed into the Siemens system that then would address data quality issues. And then the data would push further into this red component, the EDM system. The EDM system basically brought into context the network, the distribution networks. As you may know, if you have energy coming into a network, the same energy needs to be also consumed and vice versa. Otherwise, the network becomes unstable and you start having brownouts. And this was the component that would calculate this balance, what's going in and out. And then eventually, the readings went into SAP to generate the bill that would be sent out every quarter. Yeah. There was also a portal for third-party customers, and the data was also shared with either large customers or with the network operator, the Swiss-wide network operator. Then we had an inverse data flow. In order for those readings to flow from the left to the right, all the systems had to be preconditioned, so they had to be configured. They had to know about a particular smart meter specifically. And that's where SAP was pushing that data into the different systems. You see all the different arrows where the data was flowing, the master data. When I came to the company, there were a couple of issues. You can see on the right-hand side, the actual data flow of those readings was a challenge. You can see particularly in 2020, September, October, November, we had some rough times with the Tiger team trying to fix some data flow issues. And you can also see to the right-hand side, things got better as it went along. However, we also had this issue with master data. Because SAP would distribute the same information into different systems, sometimes we had discrepancies. So not all the information was exactly the same, which caused then that when we bought new smart meters, we couldn't actually use them. It was a very low percentage in terms of meters that were impacted. It was about maybe 1% where it happened. It was always due to manual issues that some people, offset by one indexes, stuff like that, only 1%. But when it happened, there was a big issue. The product owner or the product manager basically sent out an email and said, hey, we need help. Nothing's happening. We have an issue with this particular series. He sent a second email, a third email, 10 emails, 20 emails. Eventually, in one thread, I counted 70 emails going back and forth. And the issue was nobody really had the overview. Nobody knew where the issues actually were. And so we were at a point where the operations team could not access that information because it was buried in the operational systems. They could only look at individual meters, but never at a larger, set of meters. That was one of the pain points. And at the same time, management knew that if we didn't master this master data issue, we would also have troubles for the scale out of the smart meter rollout. So scaling the whole deployment by a factor of 5 obviously could become a really big headache. So I ended up putting together a proposal, moving the boulder, as Steve calls it. I pitched to the department heads. And initially, there were a few engineers amongst the audience. So I figured I'm going to show them some data models. And you can see quite easily here, we have the SAP model, we have the Siemens data model. They were close, but they were not the same. So, and funnily enough, just before I joined BKW, I happened to read the book Software Wasteland from Dave. And when I saw the situation there, I just had to smile. I was like, well, it's exactly the situation. Yet another example of what Dave described in the book of this application centricity versus the data centricity. In addition to that, there was no comprehensive documentation. So we had to reverse engineer some of the information to basically get a big picture. Then we told management what we're going to do is we're going to pull in some of the data, not all of it, just a little slice, what we're really interested in on the business level, on the smart meter information. We're going to combine that in a graph, and then we're going to look at the overlap. Where do we, where is this information consistent? Where is it not consistent? We also presented a business case. You can see here on the left-hand side, the green bars basically represent the savings. You can imagine if 70 emails are going back and forth, there's a cost to that. And management had already started collecting some of the numbers in terms of how much hours were spent on trying to solve these issues. So we were basically walking in an open door. On the cost side, there was 150,000 initial project cost anticipated with a running cost of about 60,000 a year. And that would bring us to about a break-even point of 2 years. Within the second year, we would break even. On the qualitative side, one big point was restore customer satisfaction, because obviously if the customer orders a series of smart meters and they have to wait for 6 months, they're sitting in the stock right with us, but we cannot deliver them because they're not going to work if you put them into the field. That's not satisfying, that situation. And also, I think what was also, a motivation for management was to restore this confidence in data management for the future smart meter rollout. I also allowed myself to, at the end of the presentation, to give a little bit of a teaser of what could be done. So the goal of the project was clearly re-establish the master data consistency and providing a portal for the operations team. At the same time, also said, well, maybe we can also build that situation. We can add operational data, monitoring data, and combine that all into one. And going further and further, all the way to potentially changing the paradigm to an auto discovery rather than pre-initializing everything. But I think on the right-hand side, it went a little far. So we stuck to the left-hand side here. When I look back at the Swatch use case, it took me about a year till I finally got 50,000 Swiss francs in the end. Here in this particular case, it took 20 minutes to get 150 Swiss francs to implement this particular use case. So from my side, I was very happy. We could move ahead right into the implementation. From a technical perspective, it looked very simple. I think you guys are quite familiar with that. You have the different sources. You pull in the data. You combine it in the graph. We put the low-code operations portal on top of that. We used the MetaFacts component there. Back in the Swatch use case, we used the FluidOps and the FluidOps product. Here we use the MetaFacts product. They're quite similar in terms of the philosophy. I'm going to talk about that a little bit later. And then on top of that, we put some rules, basically expressed in Sparkle queries, visualization, showing this stuff. I'm going to show you an example then afterwards, and also do some reporting. And users were also able to manually add annotations. So, for instance, if they checked a particular meter, they could leave a comment or so, or they could exclude it from the analysis or so. This type of small interactivity we also implemented here. Data pipelines, we saved some time and some budget by realizing that BKW actually had a transport component in production, Go Anywhere, that knew how to read databases, knew how to get FTP stuff and so on. We pushed that into CSV files, used Tarkle to convert in the CSV, built a little component, a little web wrapper around Tarkle. That was Reto Kmuhr from Praxis Mission, who already helped us in the Swatch use case, also helped us here to implement that, and that then pushed the triples into the place graph with MetaFacts on top. The diagram for the techies of you. Then we built a very simple ontology. You can see this is not hard to interpret. Basically, there was a smart meter class, there was a tenant class, because every solution, the Siemens, the SAP, and so they had tenants, they had their own tenant system. So we pulled in the tenants, and from every system we pulled in the individual records. Now, funnily enough, at the very beginning, I said, okay, let's combine all the data in just one object. And I went to some of my colleagues, some on the operations side, and I was like, look, guys, it's so great. You don't have to pull out data yourself anymore. It's all presented in one thing. And they kind of looked at me and they were like, yeah, it's nice, Peter. But I wouldn't want to be the person who has to kind of sort out all these attributes. And that's when I realized, well, maybe I'm not quite done yet. So the same Friday afternoon and Saturday I went ahead to actually I didn't collect the data anymore in just one object, but I imported each record individually from each source system, so that we knew the representation, how it was in the London St. Peter's system, in the Siemens system, the SAP system. And then only with the Sparkle construct query, we built the consolidated information on top of that. And that turned out actually to be quite beneficial. And we had a really nice benefit from that. I'll show you afterwards. Timeline pitch was in February. Immediate approval, which was fantastic. Then the first 3 months we spent on talking to the people who had the data and negotiating with them how we can get to the data, which report or which view and so on. testing, and then in July we started building up the infrastructure. In August we had a MetaFacts instance up and running and the CI/CD pipelines, and then September, October were the main implementation months for the portal and the data ingestion. In October there was the first demo. That's where I received that particular feedback from my colleagues, and I changed the analysis to this, I call it closed circle analysis. Then was the handover and the documentation. The whole net effort in terms of invested time was about 5 person months. There was help from the infrastructure team. There was help from an external that we used to build this wrapper. But overall, it was about 5 person months. And I do think this is quite efficient compared to the complexity of the issue that we have. Now, I'm going to show you the portal. The portal established really a new visibility for the operations people. Up until now, they went into different searches, into different applications. They had to search meter by meter, write things down on a sheet of paper, an Excel sheet. And so this is what they saw once the application was done. It was basically a list of the smart meters. You could do a back-end filtering here, or you could do a filtering for a specific serial number, so in the front end. And you already here see the statuses. We translated the up and down status into different colors, and also the source system is already here represented by its color. So SAP, for instance, is orange. So people, when they saw a picture like that, they could pretty quickly say, oh, that looks good to me, nothing to do. And we also implemented a few rules that then would augment the data of a particular meter with this check mark. So it was a green check mark, all was good. And if it was a red cross, then it wasn't. So we tried to make it visible to the operation people as quickly as possible. Then when you clicked on a particular meter, you came to this page. You see there's a little picture, there's the consolidated information, and here then you see these individual records from the individual source systems. Here you can see there's just one record, here's one record, here's one record, all fine, they all look green. And one visualization we did then is we didn't just show the master data, but from the data that we collected, we reconstructed this flow, this data flow of the readings. So here you see quite easily the source, the initial record, or from the Landis and Gear system would deliver data to this particular record, and then that would deliver readings to this particular record in the SAP system. Now, if we look at this, it's okay, it looks pretty simple. Where it gets interesting is in the next slide when we actually start to have weird records, or we start to have zombie records. Here we have an example where we have 2 records in SAP. Which one is the current one? Which one is the active? We're not quite sure. Here we have 3 records in the Siemens systems, and we have 1 record in the Landis and Gear and 1 record in the one portal. And the nice thing was, because we had all the relevant data in the graph, we could reconstruct, as I mentioned beforehand, the flow of the readings. And you can see quite easily now here, there's the green guy. That's the first system in the flow. That would deliver then its data to this guy and then to this guy. So this would be a complete, flow in that sense. And you can see here, those 2 Siemens records, they don't have the light green arrow coming in, so meaning they don't receive any data. And this information was super hard for the operations people to extract previously, and here they basically had it presented on a silver platter. So coming to the learnings from this particular project. Obviously, I think most of you know data integration with RDF works really well. I love working with triples. You get the data, you cut the data into little snippets, you throw it into the graph. You don't have to think about tables that you have to fill or JSONs that you have to fill. You could just throw it in there. They find each other. Fantastic. I really appreciate that piece. It's a time saver. It's literally a time saver. Then the low code environment that we used, this MetaFacts platform, sped up the project factor 4 to 10. I didn't quite calculate it in this particular instance. This watch use case, we did calculate it. It's almost like you have 2 or 3 developers in addition in your team when you use this low code environment on top of it. And one funky thing is the paradigm that they're using is basically the graph is the application. And try explaining that to a Java developer who has developed Java for 10 years. That's just a no-go. I see it now that I've changed to Swiss mobility insurances with very competent people, super people who are not very knowledgeable. But just this paradigm shift for them is super hard. The graph is the application. They're so used to writing code that takes information, they write it down in the database, they grab it back out of the database, they show it back to the user. They're so used to this paradigm that realizing that the graph and the connections that they can drive a user interface, that's super hard for them. Another learning we had is in the Swatch case, as well as in the BKW case, it was not IT professionals who took over the solutions, but it was people from the domain. It was business people. The person who took over the solution here at BKW studied geography. Didn't have an IT background. Did some R actually when he was studying geography. But it's a person who was sufficiently curious about it and just stepped into it and took over the solution. So that is one of the learnings. Non-IT people can also operate this type of solutions. Maybe not quite to the point in terms of envisioning what else can be done with it, but in terms of running it, no issue whatsoever. Then one thing I had to admit after working for 10 years, 15 years in Excel or databases, my head is still preconditioned for this columnar thinking. When I integrated all the data sources into the graph, the first thing I did is basically coming back to the columnar thinking and making sure that all the manufacturer serial numbers are the same, all the operator serial numbers are the same. Doing this consistency check, like I would do in Excel, was my initial instinct. And only when I talked to the operations people, kind of got this rebuke of, Peter, I wouldn't want to be the person who has to sort this out. Only then I thought of, as I've shown to you, maintaining these individual records and realizing that I could actually look for shapes rather than checking data and fields and strings and so on. I could look for shapes in the data, basically a closed circle of the master data flow and the reading data flow. Closing this circle actually guaranteed that the right data went to the right place. And that's basically a learning from this particular project. I need to think more in terms of circles, in terms of stars, in terms of shapes to add this to my analytical toolbox, which is something that we're looking at now as well at mobiliar insurances. In the fraud cases, for instance, looking at star shapes around emails, master data use cases, again, looking at star shapes to find data that's not consistent. Bottom line, basically, of this project is nobody in the company knew how to address this situation. Emails went back and forth, fingers were pointing. The developer said, "It's not our job to debug all your stuff. It's your fault. You entered it wrong into the systems." And the SAP people said, it's not our fault. We don't know what's happening in those systems. It's we just maintain the master data. So pulling the data quickly into a knowledge graph actually helped giving this visibility to the operations people primarily, but also the developers and the SAP people, that they could see a better view. They could see a complete picture. And I think that was really a big benefit in this particular project. There's one little thing, looking back, that I would have done differently. When I sold the project to the decision makers, I did focus a lot on the pain points. So when we had the pain points more or less addressed, I said, well, it's easy now. We're going to integrate the operations data. We're going to integrate the monitoring, so the operations people have kind of an operations bridge. And interestingly enough, the answer came back of, no, Peter, we cannot do that. And then I was like, well, why can't we? We need to put that into a different system. And that's where I realized that people from working in an industry for 5, 10, 15, 20 years, they're still preconditioned that you have one application that does one thing, and you have another application that does another thing, but you every time for a new problem, you need a new application. And this idea of integrating data in one location and covering multiple use cases, that's not obvious to all the people. So looking back, I would have prepared them a bit more in terms of what vision, what additional things we can achieve using a knowledge graph. I think that's, from my side, the story.
Very cool. Lots of comments in the chat about the graph is the application. Lots of people, hearty agreement there. Adam Kimball threw out shapes is also the key for any sort of graph ML. So you mentioned shapes is important there. Questions, hands raised or in the chat for Peter. Or did a few people step away for lunch? Here's a good one. What's next?
Well, for BKW, what's next is they keep operating the solution, and they're also going to integrate further. I think they've already integrated further information like channel. It's another master data issue that they have different definitions of those channels in different systems, and they're not aligned. For me personally, what's next is I'm now working with Swiss Mobility Insurance. They already had a graph project in place, an enterprise data catalog, and I'm now with them and helping them to develop further use cases. As I've mentioned before, I'm talking to a range of people, the legal department, that they can track, see positions where they're working with what companies, the fraud people, that they can get a better overview of cases that they need to analyze, master data people, developers that need to migrate old components and refactor them, the architects that want to show the dependencies within the applications and the technical components and so on. So there's a range of different use cases. And just from talking to those people, I do feel there's a hunger. There's a hunger for relationships. I've heard the one expression I've heard 3 times now from different people. Wow, this is exactly what we need. That's when I showed them a graph, basically showing dependencies. It was a developer, it was a security person, and what was the third one? I think it was an architect who said that's exactly what we need. Yeah. So I do believe there's a hunger out there, and we're going to satisfy it with graph.
Dave had a question. I went ahead and brought him on stage. Dave, we should be able to hear you.
Yeah, I met some guys who consult the electric industry here in the US, and they claimed that we're only using about 1% of the data that comes off of smart meters, mostly just billing, whereas we should, I don't know, demand planning and outages and all kinds of stuff. Is that what you're finding?
Totally. Yeah. The vast majority of the reading data was sitting in this Siemens component, and we didn't even know how to get the data out. So the data scientists wanted to look at it, and basically what we could offer them was an export, a one-time export of the database. It was more than a terabyte of readings. And the application did not have the proper interfaces to just export it. So that was just a graveyard for reading data. For the billing, obviously, was used, but then these were specific readings, maybe once a month or once a quarter, that they were taken out. The rest, daily information, was not used. I could totally confirm that.
Right. Yep. Yeah, I think there's a huge opportunity there, right across the industry.
Fully agree. Cool.
I think there was one additional question that came up here.
Yep. Do you think the graph model can be changed depending on the targeted question? Let's just put in the chat.
Can the graph model be changed specifically on a question or a query? I mean, you can always generate a temporary graph out of the existing data using a construct. On the other hand, if for performance reasons, I probably then eventually would change the structure of the graph. But I do think that the graph basically is something in between, the operational systems and the fully analytical systems. The graph in itself is already quite friendly to analysis. So if you have global queries, obviously over the whole data set, it's going to be slow. But you have local or regional queries, those are very fast. And because it's so open, the graph, it's very, very analytical. One thing our fraud people are actually quite surprised about, that I'm now talking about mobility insurance, that they could start anywhere in the graph. They could start at a particular person, they could start at a particular contract, they could start analyzing at a particular car, for instance, that had damages. They could start looking at incidents, and they were not used to this because they were forced using the operational systems to just go and look follow specific paths and specific entry points. And the graph is this analytical, open, generic model that allows you to start analyzing anywhere.
That's a great point, Peter.
There was a quick follow-up one. It says, so in practice, do you make some temporary versions of the model to optimize the performance of the application in question?
In some ways, yes. The visualization that you saw with these records being interconnected with each other, that is actually purely temporary. Some of those connections are materialized, but some of the other connections are not. So we just do a matching in terms of attributes, and it's a Sparkle query on top of it that then generates, a temporary graph, which is then visualized by this Ontodia component that we're using, which is part of MetaFacts. Yeah. So definitely we have temporary components there as well. Yeah. In terms of performance, something that we've realized is if we have this list of 80,000 smart meters, initially took us 2 minutes to download the whole list. Now, the operations people, they were happy because it took them a week before to generate something similar. They were ready to wait for another 2 minutes to just get the same data. And we realized that then, for instance, the firewall slowed down transmission, or that compression was not enabled. And that then got us down to 20 seconds for a download. So there is optimization potential also in the IT infrastructure.